Right, if you're going to attempt to finish your assignment for Monday, it might be a tall task without understanding a little bit more about Euler's theorem. And we'll talk about this more at class on Monday, but if you have some mod that's a positive integer and some other number, also an integer, where those two numbers are relatively prime, then the base raised to the phi of the mod base is always congruent to 1 mod m. We're not going to go through the proof, but this is something to definitely get into your notes, that if these are relatively prime, I can raise it to the phi power and not to the full power of Fermat's little theorem. So I just want to take this and kind of show you how this works out. So once again, a number raised to the phi of the mod base is congruent to 1 mod m. So if I were to take something like 8, which the phi of 8 is 4 because you throw out the even numbers, 3 raised to the phi of 8, or 3 raised to the 4th power, is 1 mod 8. It doesn't matter if this is a prime number or not. This will always work if I know the phi of something behind it. To take this a step farther, if that's true, then a number raised to 1 less would be equal to the phi of m, which makes sense. And if that's the case, then 1 less must be the inverse, or the number that will make that cancel out. So there is some power to that. I would definitely encourage you to look through examples 6.19, 20, and 21 as you have some time. Once again, in a cleaner variety, a number times the phi to 1 less is equal to that, which would be an inverse, as explained just a second ago. I just wanted to show you one example played out. So if you had 5x is congruent to 3 mod 14 and your goal is to solve it for x, there's many ways to do it. One of the ways to do it would be to keep adding 14s. That's still true. A second way would be to use Fermat's little theorem, because 5 to the 13th is 1 mod 14. However, if I know that the phi of 14 is 6, I can take 5 to the 6th power and know that that's congruent to 1 mod 14. So to get 1 on this side, I'd have to multiply by another 5 to the 5th, making 5 to the 6th combined, which is a 1. By doing that on the other side of the congruence, I'd have 3 times 5 to the 5th mod 14. To break this up, I notice that 3 times 5 is 15, which is a 1, and I can drop out one of the 5s and the 3 right off the bat. Leaves me with 5 to the 4th. There may be other shortcuts to get there, but 5 to the 4th is 625, doable on a calculator in my head, and doable that the answer would be 9 mod 14. So to go back, you need to be able to take and use the phi of number in the power in something that's called Euler's theorem. I'll explain more as we get to class next Monday. Thank you, but this should be able to help you do the rest of your assignment.